Okay, welcome to today's class. We're going to be looking at section 1.3 and learning about algebraic expressions. We're going to look at adding, subtracting, and multiplying those, and then eventually start with factoring just a little bit, and then factoring will be the focus of tomorrow's class. Okay, a couple definitions to get us started here. We've got the definition of a variable. A variable is a letter that can represent any number from a given set of numbers. And basically, we're going to see our variables be like x, y, and z for the most part. And we'll be looking at combining these together using addition, subtraction, multiplication, division, roots, and powers, and so forth. So an algebraic expression with variables is going to be some combination of our variables and this addition, subtraction, multiplication, division, and so forth. So we can see some examples of some algebraic expressions here where variables are combined with different powers and different operations to combine those together. Okay, polynomials is a type of algebraic expression that we're going to work a lot with. And so you can see the general form of a polynomial here. This looks very abstract and generic, and I just want you to kind of understand what it's representing. Each of these a sub n's or a sub n minus 1s would be a coefficient or a number in front of that. Then you'd have x, and your n needs to be a non-negative integer, so something like x to the third, x to the fourth, those type things. So we'll talk about degrees and terms on the next slide and show some examples of those. But a couple terms to be familiar with. A monomial is just simply when we have one term. We know mono means one. So a monomial is going to be a polynomial with one term. A binomial is going to be the sum or difference of two monomials. A trinomial would be three monomials. And then beyond a trinomial, we just generally refer to it as a polynomial. So a polynomial might have many terms to that expression. Okay, so here's some examples of some polynomials that we would be working with. If you notice, they all have number coefficients here in front of those, and each of our exponents are non-negative integers. This one has three terms, so this is one term, two terms, three terms. And the highest power is going to be the degree. It's not necessarily the first term's power, it's the highest power. So this one has a power of 1, of 2. This one has a power of 1. This one would have a power of 0, and so the highest one would be 2. Therefore, its degree over here is going to be 2. This one would have a degree of 8. This one is not in descending order. Typically, we want to see our polynomials in descending order. So if it's in descending order, we would have this term first. This is going to be our highest power, so our degree of this one would be 3. This one would have a degree of 1 that's understood to be here. So it'd have a degree of 5. And since this is just a constant, it would have a degree of 0. Okay, so we want to look at being able to add and subtract polynomials. So when we're adding and subtracting polynomials, just think of it as like combining apples with apples and oranges with oranges. So these terms here, we want to look for the ones that are alike. So we've got an x to the third here, we've got an x to the third here. So we've got one here and one here. If we add those together, that's going to give us 2x to the third. So we don't do anything with our powers when we add these, we just work with the coefficients in front of those. Okay, if we move on to the x squareds, we have a negative 6x squared and a positive 5x squared. So negative 6 plus 5 is going to give me negative 1x squared. Okay, here we have a 2x and a negative 7x. If I combine 2 and minus 7, I'm going to get a minus 5x. And then I'm going to have a plus 4 because I don't have anything to combine with that. Okay, with the difference, when you have the difference, I would suggest going ahead and distributing this negative through before you start trying to combine any like terms together. So we would have an x to the third minus 6x squared plus 2x plus 4 from the first polynomial. And then I'm going to go through and change the sign of everything in the second because of the subtraction. So I have minus x to the third minus 5x squared. And then negative times negative is going to be a positive 7x. Now that I've distributed the negative through, I can go through and combine like terms. So if I have a positive and I have a negative x to the third, those are actually going to cancel out. Here I have a negative 6x squared and a negative 5x squared will give me negative 11x squared. I have a 2x and a 7x is going to give me a 9x, and then I still have the 4 that doesn't have anything to combine with it. Okay, so this would be my answer for this one. Okay, moving on to multiplying binomials. Okay, most of you are familiar with FOIL, and FOIL only works when you are multiplying binomials. So 2 terms times 2 terms. If we have anything besides 2 terms times 2 terms, FOIL is not going to work. So what is FOIL? FOIL is an acronym for first, outer, inner, and last, which just tells us a method for multiplying these binomials together. So if we do first is going to be the first of each of our terms here. So we're going to multiply 2x times 3x. So this goes back to when we were multiplying like bases. We're going to have to add our exponents. So we're going to have 2 times 3 will be just 6 because we are multiplying 2 and 3 together. And then x times x is going to give me x squared. Okay, outer, I'm going to do the outer term, so this term and this term. I'm going to multiply those two together. So 2x times negative 5 is going to give me negative 10x. Inner, this term and this term will be my inner terms. So 1 times 3x will be 3x. And then last, 1 times negative 5 would be negative 5. Okay, so I will have some like terms I need to combine together here. So I have 6x squared minus 7x and then minus 5. And that would be my final answer. Okay. So basically FOIL is just a way to keep it organized so that we make sure that every term in the first one gets multiplied to every term in the last one. Okay, I'd like for you to practice this one. So pause it and try it. Make sure that you're good with doing FOIL, and then you can check your answer. Okay, check your answer and make sure that you got this one correct. If you didn't, then go back and look and see maybe which terms you didn't have the right answer on. Okay, moving on. Not every time that we multiply polynomials are they going to be a binomial times a binomial. So in this case, you see there's a binomial times a trinomial. So our FOIL method is not going to work. So there's a couple methods that I want to go through. The first one is the distribution method. Basically, the distribution method just says that everything in the first polynomial is going to need to be multiplied to everything in the last polynomial. So we're going to start and we're going to do 2x times everything. Okay, so 2x times x squared is going to give me 2x to the third because I need to add my exponents. 2x times negative 5x will give me negative 10x squared. 2x times 4 will give me 8x. And then I'm going to go and I'm going to distribute and multiply everything by the 3. Okay, so 3 times x squared will give me 3x squared. 3 times negative 5x will give me negative 15x. And then 3 times 4 will give me 12. Okay, from here I need to go through and combine like terms. So I don't have anything to go with the x cubed term. Negative 10x squared and positive 3x squared will give me negative 7x squared. 8x minus 15x will be negative 7x. And then plus 12. And this process would work if we happen to have a trinomial times a trinomial. We just need to make sure that everything in the first term is then multiplied to everything, or everything in the first polynomial is multiplied to everything in the second polynomial. We need to make sure everything gets multiplied to everything else. Okay. So some of you may have seen this type problem done with the box method. With the box method, you're going to draw a box here. Okay. And I like to write the longer one across the top. So I'm going to have x squared minus 5x plus 4. And then down the side, I'm going to put 2x plus 3. Okay, so I'm going to make it into a box here, like draw my boxes in. And now everything on the top side of a box and the side are going to get multiplied together. So 2x times x squared gives me 2x to the third. 2x times negative 5x will give me negative 10x squared. 2x times 4 will give me 8x. 3 times x squared would be 3x squared. 3 times negative 5x will be negative 15x. And then 3 times 4 will be 12. Okay, so our like terms are usually going to line up on these diagonals here. So when we write this out, we've got 2x to the third from this block. We combine these two together, negative 10 and positive 3 will give me negative 7x squared. Combine these two together and I get negative 7x and then plus 12. And you can see that these two answers are the same. So it's just a different method for solving the same problem. If you're more familiar with the distribution method, then use that. If you're more familiar with the box method, then use that. I'm perfectly fine with either method. Okay, so here's one that says startup, but we're just going to practice with this one. So we want to practice. I'm going to give you a minute to find the product for this one. Okay, take your work on this one and make sure that you've done it correctly. If you did the box, you should get the same answer, but your work may look a little different. Okay, so looking at the special product formulas, these are some rules that I'm not really going to focus on a lot because if you know how to multiply two binomials by FOILing it, you don't necessarily have to know all these special product formulas. I will say, like, if you have two binomials that are identical except for opposite signs, what's going to happen is your middle terms are going to cancel out, and so you don't have a middle term when you FOIL that out. So that's just why it's called a special product formula for that. Here, if you have two parentheses that are identical, then when you multiply those, you end up doubling the product of the two for your middle term. If they have the same thing with two parentheses that are identical that you're multiplying together, then you're going to have, and it's a negative, then it would be negative 2 times the product of the A and B. I want to focus on these last two here because they really are helpful formulas. If you start trying to multiply 3 binomials together, it can be very difficult to keep track of everything because you would have to multiply 2 of them together and then take that answer and multiply it to the third one in order to get it all multiplied out. So this is a helpful formula to use. So on the next couple slides, I'm going to go through some examples using the fourth and fifth formulas. So just to kind of give you some orientation to it. If we're going to multiply a plus b and all that's to the third power, that would be the same thing as a plus b times a plus b times a plus b. And we'd have to FOIL this, take that answer, and then multiply it out with this. So it could be a long and drawn out process. So this formula is going to shorten it for us here. So this is the one we would want to use because for this problem we have the plus here. So we want to use the formula that has the plus that I've identified for you here. So we need to figure out what our A and our B are. And this one is pretty simple. A is just going to be X and B is going to be 3. Okay, so we just want to match this up with A plus B to the third so that we can then go in and plug everything in here. Okay, so here we're going to have A, we're going to replace with the X. So we'll have X to the third plus 3 times X to the second times 3. So we're just replacing the A and the B with the X and the 3. Then we'll have plus 3 times X times 3 squared. And then finally plus 3 to the third. So I definitely recommend just taking a step where you go in and you write it out. Don't try to simplify a lot, just write it all out. You can go back later and simplify it. So here we've got x to the third. On this one, 3 times 3 is going to give me 9x squared. Here we've got 3 and then 3 squared. So 3 times 3 squared would be 3 times 9. So 27x. And then here 3 to the third is just 27. So that's what we should get for our answer on that one. Okay, on this example here, we have another one that we're expected to cube a binomial. So we need to figure out what our A is and what our B is. Okay, so in this case, A is actually x squared and B is going to be 2. And because we have the negative here, we need to use the cube of a difference. So we need to use the formula that has the subtraction sign. And so we're going to end up with some different signs in here for our formula. You do not need to memorize these formulas. They are on a formula sheet that's located under the course resources. I would suggest printing that out if you have access to a printer and keep that available as you go through the course, because you may use that for any quizzes and tests. I'm not big on making you memorize formulas, especially formulas like this. Just know where to go get them when you need to use them. Okay, so using this one, we're going to replace every a and b with x squared and 2. So here we'll have x squared to the third minus 3 times x squared to the second times 2 plus 3 times x squared times 2 to the second minus 2 to the third. Okay, so this is going to give me, we know that when we raise it to a power, we multiply our exponent, so I'm going to have x to the 6th. Okay, so we want to do 3 times 2 will be 6, and then here we'll have x to the 4th. Okay, over here we've got 3 times 2 squared, so 2 squared is 4, 4 times 3 is 12, x squared, and then minus 2 to the 3rd is going to be 8. So we should end up with x to the 6th minus 6x to the 4th plus 12x squared minus 8. Okay, looking at this one here that we have, on this one our a is going to be 2x and our b is going to be 5. We need to go ahead and use the addition formula. So if we plug in here, we're going to have 2x to the 3rd plus 3 times 2x squared times 5 plus 3 times 2x times 5 squared plus 5 to the 3rd. Okay, if we go and simplify each of these, 2 to the 3rd would be 8, x to the 3rd. Here we've got several numbers. We've got a 3 and a 2 squared and a 5. So if we've got 3 times 2 squared times 5, that's going to be 12 times 5 is going to give us 60, x to the 2nd. And then over here we've got 3 times 2 times 25. So that's going to be 50 times 3 would be 150x. And don't hesitate to use your calculator to simplify some of these. 5 to the 3rd is going to be 125. So our answer we should see here is 8x to the 3rd plus 60x squared plus 150x plus 125. Okay, another product here that I wanted to look at. This is one of those special products where we have identical binomials but with opposite signs. So what's going to happen when we FOIL this, we're going to have our inner term and our outer term are going to cancel each other. We don't really have to worry about those. So we want to just look at the first and the last in this case. So 2x times 2x is going to be 4x squared. Here we're going to have a minus because a minus times a plus is going to leave me with a minus. Square root of y times the square root of y is going to be the square root of y squared, which we know is just y. So our answer should be 4x squared minus y. If you forget and don't notice that these are opposite signs and multiply it out, all you're going to see is that your two middle terms are going to cancel and you're still going to be left with this. Okay, here's another product. This one is a little bit tricky, and I just wanted to talk to you about it for a minute. Just at first glance, it looks like a trinomial times a trinomial, so you would either need to do a box or use the distribution method to multiply this out. But we actually can think of it like this. We put parentheses here and here. We're not changing the value of it at all, but in doing that, we have essentially a binomial times a binomial and with opposite signs, so that when we FOIL this out, our inner term and our outer term are going to cancel. So we just need to do the first term and the last term to simplify this. So I'm going to have x plus y times x plus y. Inner and outer cancel, and then I'm going to have -1 times +1 will give me -1. I can fold this out quickly, so x squared plus, and this is actually one of those other special formulas as well. If you've got identical binomials, you're going to end up with 2xy plus y squared minus 1. And just ignore this line that printed across there. So x squared plus 2xy plus y squared minus 1. So looking at this, if I were to go ahead and multiply it out, I would just have x squared plus xy plus xy plus y squared. And then I could combine those two together to get this 2x squared. So it's really just a matter of, do you recognize it and know that formula, or do you just multiply it out and do an extra step there? Okay, I want to do an introduction to factoring and just do a couple problems using GCFs, and then we'll look at the other types of factoring in tomorrow's class. So with factoring, we've got basically factoring is undoing expanding. So we've spent a lot of today's class looking at multiplying out binomials, trinomials, and so forth. So we're expanding those when we do that. Factoring is going to undo that. So it's going to take the expanded form and it's going to put it back into the factored form. Okay, so it's undoing what we've been doing so far. The first type of factoring that you will always do is to begin by looking for your GCFs, your greatest common factors. Okay, so even if you see a difference of squares, or you see a trinomial, you always have to take out the GCF before you use all the other types of factoring that we'll look at. So in this particular one here, we've got these two terms, and we just want to look and see what's common to each. So when we're considering the coefficients, we want to think what will go into both 3 and 6. So 3 would go into 3 and 3 would go into 6. So that's going to be part of our greatest common factor. And then when we look at the x squared and the x, we actually want to take the variable to its smallest power because that's what's common to both. So we'll have an x to the first. And then when we take this out, we want to divide it out and take it out. So I took the 3 out and I took one of the x's, so I'm going to be left with 1x. Here, 3 goes into 6 2 times, and I took the x out. You can always check this to make sure that you factored it correctly. Just multiply it back out. So 3x times x would be 3x squared, 3x minus 2 minus 6x, and so it checks. So my answer is the 3x times x minus 2. Okay, so in the previous work that we did today, we would have had a problem like this and we would have expanded it. But now we're going to take a problem that's expanded and we're going to put it back in its factored form. Okay, here's a couple other ones to look at. If we look at this, the 8, 6, and 2, you can see that 2 is a common factor there. We're going to take a 2 out. On the x's, we have an x to the fourth, an x to the third, and just an x. So I'm going to take an x out, and then I'm going to have a y to the second. 2 goes into 8. So remember this, because factoring is basically division, we divide the 2 into the 8 and it goes 4 times. We have 4 x's and we took one of them out, so we have 3 left. We took all of the y's out. 2 goes into 6 3 times. We had 3 x's and we took 1 out, so we're down to an x squared. We had 3 y's and we took 2 out, so we're down to a y. And here 2 goes into 2 1 time, so we'll have 1 as our coefficient there. We took the x out and we took 2 of the y's out, so we'll end up with a y squared. If you want to check it, multiply it back out and make sure that you end up with this, and it should check and be correct. So the greatest common factor would be this 2xy squared. When we come down to this last example here, I want you to think about this in terms of one term and one term. It looks much more complicated than that, but think of it that way, because if this is one term and this is one term, then we do see something that's common, and that is this x minus 3. So we can take out the x minus, okay, we can take out the x minus 3. That leaves me with this 2x plus 4 in the first term. So looking at this first term, I took this out, I'm left with this. And then over here, I took this out, so I'm left with the 5. So I'm going to have x minus 3, and then I'm going to have 2x, and I can combine these two together. 4 minus 5 would be negative 1. And so this would be the factorization. If you don't recognize this, then you're going to end up having to multiply this out by full, distribute this, combine your like terms together, and then factor it. That's a much more complicated process than just simply looking at these common factors that you have here. Okay, so we're going to stop at this point today. We'll be picking up with factoring trinomials. We'll look at grouping and some other processes for factoring. So if you have any questions on tonight's homework, feel free to reach out to me, and we'll pick up with this tomorrow.